Hi, my name is Manish Gupta, and in this video, I'm going to talk about supernatural instructions, generalization via declarative instructions on 1600 plus NLP tasks. So let's first talk about what is this supernatural instructions. Well, it's a benchmark of 1600 plus diverse NLP tasks along with their expert written instructions. Here is an example. So, or rather, here is an understanding of how this works. Let's say if you have an input, she chose to make a salad for lunch tomorrow and Sunday. The question is, how long did it take for her to make a salad? And then you can basically give some instructions, respond yes if the sentence contains an explicit answer to the given question, and otherwise answer no. And then the output could be no. So there could be some tasks which you use for training purpose and also provide instructions, question, and output answer. While there are other tasks which are called as evaluation tasks, for which you have only the instructions and the questions, and then hopefully at test time, the model comes up with the right outputs. The benchmark actually consists of 76 different task types like classification, extraction, infilling, sequence tagging, and so on. It has 55 different languages, 33 domains, 576 non-English tasks. So out of 1600 or so, about 576 are actually non-English tasks, and they have been contributed by 88 different NLP practitioners. Um, the benchmark was built to be able to actually answer this question: how well can an NLP model generalize to a variety of unseen tasks when provided with task instructions? And this is the exact setup that you see in the picture. At train time, you provide some tasks, and then at evaluation time, you give data about some other tasks, and hopefully the model generalizes and performs those tasks equally well. The data and models are publicly available from LNAI, and have a look at the data and models. So what are the tasks in this data set? Well, compared to other interesting data sets like natural instructions, a smaller version of this data set and the benchmark, right? Prompt source, which was used to train T0 model, right? FLAN, InstructGPT, compared to all of those kinds of things, here the range of tasks is very diverse. Lots and lots of different kinds of tasks. The size of the bubble here indicates how many tasks belong to that particular category. So lots of translation related things, question answering, program execution, text categorization, sentiment analysis, question generation, common sense classification, text completion. So many interesting diverse NLP tasks are a part of this data set. In fact, here is a split with respect to languages. So I'm not shown all the languages here, but just quickly to notice, a lot of those tasks are English only, but then there are tasks across other languages also. Similarly, most of those tasks essentially here's the domain split. So many of those tasks are news oriented, but then hey, the tasks actually are related to several other domains that you see there. Now, typically, the tasks are specified using a task instruction, and the instruction actually consists of three main components: the task definition, positive examples, negative examples, these three things. The task definition actually explicitly states what the task is about, right? And in fact, in the benchmark, the average definition length is about 56.6 words per task. So fairly large descriptions, right? There are a few bunch of positive examples. So, and each example actually consists of an input, an output, and an explanation, right? So the benchmark actually has about 2.8 positive examples per task on average, right? There are some negative examples also which are provided. For example, there's an input, there's an output, and then there's an explanation why the output is wrong, right? So the utterance only takes the negotiation forward and there is no side talk. Hence, the correct answer is no, and therefore the provided answer yes is false, right? So there are negative examples also, and the benchmark has about 2.4 negative examples per task. At test time, of course, you give evaluation instances about some other task which was not seen at the train time. And overall, there are about 3,106 instances per task and a max of 6,500 instances per task. They actually capped it to a max number of instances so as to not cause bias in the data. So how are the instructions provided? As we saw on the previous slide, instructions basically consist of three parts: definition, task definition, positive examples, and negative examples. Each positive example actually consists of input, output, and explanation, and each negative example also contains the same things. Instances, essentially, there's a task instance, which basically consists of an input and an output, which is provided to the model. At test time, of course, you just provide the input and verify if the output matches with the ground truth. Okay. These instructions are all manually curated with automated as well as manual verification. So several rounds, 3 rounds specifically of verification were done to ensure that the instructions are high quality and make sense. Here is an example of the task for textual entailment. So the idea is that you are given 2 sentences, the premise and the hypothesis, and you have to indicate one if the first sentence entails the second sentence. Otherwise, you have to basically mention 0. Here is a positive example. Here's a negative example for the task. And here is an instance which is passed as input, and a valid output would be 0, which has to be predicted by the model. Here are other examples. Cause effect classification is a task. Here, the idea is that you are given 2 statements, and the model must judge whether the second sentence is the cause or effect of the first one. So if it is the cause, then so label the instance as cause or effect based on your judgment. Sentence is separated by a new line character, right? So essentially, the model is supposed to sort of predict cause or effect. Another task is co-reference resolution, where you are given a question containing a blank and 2 options. So you should pick the best option to answer the question. So it's sort of a co-reference resolution task provided as a fill in the blank in some ways, and you're supposed to sort of choose from one of the 2 options, A or B. Right. Here are some more task examples. Word analogy task. In this case, 2 analogies that relate actions to the tools used to perform the action are given, and in the form of A's to B, C's to what, right? So for example, eat is to fork, cook is to what, and the output should be pan. That's the idea. So they are analogy tasks essentially. There is also this question rewriting task, where the idea is that you are given a disfluent question. So, and you have to basically convert it to a proper question like that. Um, there are other tasks like grammar error correction. So you are given an input sentence with incorrect grammar, and you have to output a sentence with correct grammar. Or data to text kind of tasks where you are given facts about some entity, like Aromi is the name of the entity. Restaurant, it's a restaurant, and you eat English food, and it's in the city center area, and you must come up with a natural language 1 sentence description which encapsulates all these facts nicely. Okay, it's also called as fact to text or table to text or data to text, right? Arumi is an English restaurant in the city center. Here is another one, overlap extraction. So the idea is you're given 3 sentences in this task as input. You have to read them and then identify a noun phrase or which is a person, place, or thing, or an event that is shared between all these 3 sentences. Of course, it's not going to be written with exactly the same words, but they denote the same underlying person, place, thing, or event, right? So and as an output, you're supposed to basically bring out those phrases nicely. So for example, here are some 3 statements, right? So 4 employees of the store have been arrested, but its manager, herself a woman, was still at large Saturday. Said Goa Police Superintendent Karthik Kashyap. Your second sentence, if convicted, they could spend up to 3 years in jail, Kashyap said, right? And the third one is the 4 store workers arrested could spend 3 years in prison if convicted, right? So here, something that appears in all the 3 sentences has to be indicated, and that's the 4 employees of the store, right? In the second sentence, they're referred using they, and in the third sentence, the 4 store workers. So that's the output that they expected. Okay, it's an interesting co-reference kind of a task, yeah, called as overlap extraction. Yet another task is title generation. So you're given a long document, and you have to generate a short title for the long document. Of course, the title should be like a title. It should convey the main idea, event, topic about which the document is being written. Yeah. One more task is keyword tagging task. Here, the idea is you're essentially given an abstract, and the idea is to generate a keyword or a noun phrase that best describes that, right? So, which is the focus or the contribution of the of the paper on the abstract, right? So that's that. And well, it may or may not be one keyword. You could generate more keywords, but the point is that you have to take the abstract and generate keywords. Right? So there is a large variety of tasks. I just pinpointed a few of those which are interesting. There are, of course, many more interesting other tasks as well, but I just sampled a few and just talked about a few of those tasks. The benchmark, as part of the eval set in the benchmark, there are about 15,000 instances, max of 100 from 154 tasks across 12 different categories. So remember, the benchmark has 1600 plus tasks. 154 of them are actually used for evaluation. Okay. 119 of these 154 are English, the remaining are non-English. The common metric that is used is ROUGE-L. Now, ROUGE-L is the LCS distance-based metric, which is a reasonable metric to use to evaluate NLG methods. They propose several baselines before they actually talk about their own models, right? So the baselines, simple baseline is copying the demo output. So they're basically saying that, hey, you have been given a few positive examples or demonstration examples. Maybe randomly just choose one of them and copy the output. Now, this is basically a random baseline, and therefore the idea is that its accuracy should be as good as a random or a majority-based baseline. Okay. You could also do copying instance input. So, you can actually take whatever is the input and just put it out as the output. Now, this kind of stuff can perform really well when the target output is basically the same as the input or matches the input very much. For example, question rewriting or grammar correction. In those cases, you do not expect too many changes in the final output. Okay. Pre-trained models. So, well, you could also use the 11 billion parameter T5 model, which has been further pre-trained using language modeling objective, or 175 billion GPT-3 model, or InstructGPT models like the they in particularly use the text DaVinci 001 model, or the T0 model. They're all interesting pre-trained models to act as good baselines. Okay. They also come up with a Oracle upper bound estimate. So the idea is that they fine tune an Oracle model on the task label instances. So these instances, these particular 154 tasks, in general, when they're testing their model for zero-shot generalization, 154 tasks were not used for training the model. But hey, you could actually try to use these tasks also as part of training. Not the exact same labeled instances, but different labeled instances, but belonging to these test tasks also, and then verify how good the model fine-tuned on those test tasks performs on the same tasks, but with different instances. Okay, of course, there's no train test leakage, but there's no zero-shot generalization that is being tested in this Oracle model. Okay. So for this one, they basically fine-tune a 11 billion parameter 35 model or a 3 billion parameter MT5 model on the 35 non-English tasks. 11 billion parameter model for the 119 English tasks, and 3 billion parameter model MT5 model on the 35 non-English tasks. Okay. Now, finally, about their own model, well, their model is called as Tk-Instruct or mTk-Instruct. So Tk-Instruct is a multitask trained model, which is a T5 model and has been trained for English tasks. MT5-Instruct is also a multitask training model, and it is basically obtained by training the MT5 model. Okay. So now let's quickly talk about the results. What do the results look like? So how do Tk-Instruct and mTk-Instruct perform, right? So here is a summary of the results. Um, well, here are the heuristic baselines, copying instance output and demo output. So, and what is being shown is how they perform on English tasks versus the cross-lingual tasks, right? So what you observe is that models that leverage instructions, these ones, T0, InstructGPT, Tk-Instruct, mTk-Instruct, these two have been proposed by them in this paper, right? So they actually show strong generalization to unseen tasks. You see, these results are better in general compared to the heuristic baselines for sure. And also equivalent models are actually better compared to even the pre-trained models, right? So for example, T5LM has been used to train Tk-Instruct, and clearly, as you see, the 11 billion parameter model is actually performing almost less than half as accurate as Tk-Instruct model, right? Similarly, if you look at this 175 billion parameter model, well, it's the 45 versus 52. So of course, InstructGPT is performing way better compared to GPT-3, right? So Tk-Instruct outperforms InstructGPT. Interestingly, amongst the instruction-based models, the models that they propose, Tk-Instruct and MTK, they perform better compared to the other instruction-based models, right? So 62 is larger than 51, as you see, right? Although the model has 11 billion parameters compared to InstructGPT, which has 175 billion parameters, 16 times more parameters, right? However, if you notice, the LCS, the Rouge LCS measures are not that great. So it's still 57, 61, 62, and so on. There's a lot of room for improvement. Okay. Now, on the other side, what you see is different kinds of models which are being shown here. And what is plotted is essentially the Tk-Instruct model, 3 billion parameter model, and 11 billion parameter model. What you also observe is that there are two curves, one for the human evaluation. So how good do you think is the output versus the Rouge L-based evaluation? So what people observe is that Tk-Instruct generates responses at least as well as ground truth for 77% of the test instances, which is really good, right? I mean, so this is human evaluation, remember? This is human evaluation. And the interesting part is human evaluation and Rouge-L seem to be very highly correlated. In fact, the correlation coefficient of these two curves is 0.998, which is insanely, crazily large correlation. So basically saying Rouge-L, the metric Rouge-L that they chose for these tasks aligns really well with human perceived quality. So how does Tk-Instruct perform? Well, it performs really well across different tasks. Here are different tasks being shown, right? You see there are like 12 different tasks being shown here. And the output is being shown for various kinds of models. Surprisingly, the copying demo output model is pretty good in some ways, right? It's reasonably good. However, of course, the best model is Tk-Instruct with 11 billion parameters. It's better even compared to InstructGPT, which is 16x the size of the model. Tk-Instruct consistently performs better on all the task types, and there is a sizable gap compared to supervised training compared to the supervised trained model. Okay, yeah. One thing I forgot to mention is that yes, there's an upper bound estimate, which basically shows that an oracle model, of course, performs really well. But hey, this is the upper bound, so there is no such oracle. I mean, this does not really test for zero-shot generalization, and that's that. Yeah. So from a zero-shot perspective, Tk-Instruct and mTk-Instruct are way better compared to other models that were tried out. Now, how does the model scale? Well, they try to look at scaling from three perspectives: number of training tasks, number of instances per training task, and number of model parameters. As you see, there is, as number of training tasks increase logarithmically, there's a linear increase in the accuracy. Similarly, as the number of model parameters increase logarithmically, there is a linear increase in accuracy, right? Which is positive. Okay. The model performance sort of saturates when the number of instances per task are about 60, 64, right? And it does not really increase even if you increase the number of instances beyond that, right? Uh, what these charts essentially show is that increasing the diversity of the training task is a very nice way of improving the accuracy, and it's an alternative to scaling the model sizes. Of course, you can get more accuracy by coming up with larger models, but then larger models mean a whole lot of problems like large RAM size, more latency, and so on. So increasing the number of training tasks is a very nice alternative, seemingly so. Right. Now, lastly, what happens when we change instruction format? So the authors actually tried out by just training. So on the rows you see training encoding, and on the columns you see test encoding. So they tried to build models by training using just the task ID, which is just the name of the task, right? Definition, the task definition, one positive example, definition plus one positive example, two positive examples, definition plus two positive examples, and so on, right? They actually gave all the way until four positive examples, right? So what they observed is that impact of adding more demo examples is negligible. Just to give one example, and this more or less performs equally well as compared to passing four examples. Okay. Negative examples help a little bit. Explanations actually decrease performance. So what they observed is that passing a positive example is good enough. You may or may not want to give explanations or negative examples. Okay. Now, they also try to sort of check if you essentially train using a particular encoding and test using some other encoding, what happens? So interestingly, definition only models cannot generalize. So if you look at definition only models, well, this is a row. You see that they cannot generalize to example only test encodings. And similarly, basically we're talking about these ones, right? So they cannot generalize to example only test encodings, the ones that don't contain the definition, right? Similarly, if you basically are using models that have been trained on examples only, then they don't generalize to definition only test encodings. Okay. The other observation is that a model which is trained with definition and positive examples sort of remains robust for different kinds of encodings. So that's the other interesting observation. The last row here. Okay. So that's that. In summary, in this video, I talked about supernatural instructions, which is a benchmark of 1600 plus diverse NLP tasks and their expert written instructions. There's a great variety across domains, languages, and tasks in this benchmark. Instructions consist of a task definition, positive examples, negative examples with explanations, input, output, and explanations. And what they observed from their experiments when they trained their Tk-Instruct and mTk-Instruct models, they observed that the models that leverage instructions actually show stronger generalization to unseen tasks than traditional GPT-3 or T5 plus LM models. And clearly, their own proposed models, the Tk-Instruct and mTk-Instruct, seem to outperform the InstructGPT model, which is more than order of parameters, both from the English perspective as well as the multilingual perspective. So pretty positive outputs from this paper. And again, this is probably the first time that such a large number of NLP tasks have been proposed in any benchmark. So surely something to look at. Okay. Hope you like the video. Thank you for watching. Here is my LinkedIn and here is my homepage. Feel free to connect with me or look at my research on my homepage. Thank you.